what you learned yesterday to do the rest of this chapter. Let's just review what interval notation is again. Over here, if you're going to see a less than or a greater than sign, remember less than faces the left. It's like a bow and arrow and it's facing the left. You're going to use open circles. If it's less than or equal to or greater than or equal to, you're going to use closed circles. And you're going to use parentheses for open circles and brackets for closed circles. And the infinity or the negative infinity, you always use parentheses. So here is your little table to help you do this today. And I'm going to refer back to that table on the first couple of problems. You're going to do 3 things on every problem today. The first thing you're going to do is solve for x. So I'm going to subtract 1. 2x is less than 4. Divide by 2. X is less than 2. So there's my first thing I'm doing. I solve for x. X is less than 2. Less than faces to the left, and that's why I know it's less than. The second thing I'm going to do is make myself a number line. When I make my number lines in this class, I want you to always have a 0 on your number line. And show me where 2 is compared to 0. Isn't 2 to the right of 0 on the number line? I do not want you to, if it's the number 10, to write 10 slashes, or it's 2, you have to make 2 slashes. You just have to show me where 2 is compared to 0. Notice that there is no line underneath the less than. If there is no line, you are going to use an open circle. That's why there's an open circle right there. There is no line right there. And I know I have to shade to the left because less than is left. The next thing I'm going to do is write my interval notation that you learned yesterday. I start over here on the left-hand side and I work my way to the right, just like you read a book. Notice that it's shaded in, so I know that my answer needs to start at a negative infinity, and there's always parentheses. And you're going all the way from a negative infinity to a positive 2. And since it's an open circle, you use a parenthesis attached to it. Final answer. You need to do 3 things on every problem. I'll say it one more time. You need to solve it. That's step. You need to graph it. And you need to state interval notation. So you need to do 3 things on every problem. Okay, we're just going to do a couple more of these, and that's all we're doing today. But I know you need a few more than just one. So here we go. Let's do another one. A negative 4x is greater than or equal to 8. The first thing I'm going to do is solve for x by dividing both sides by negative 4. So x is, reminder that I divided by a negative number, and since I divided by a negative number, I have to switch my sign to less than and equal to a negative 2. 8 divided by a negative 4 is a negative 2. Do you notice that my sign changed? Okay, now I'm going to make a number line. Always put 0 on your number line. Show me where a negative 2 is. A negative 2 is on the left side of 0. Notice that there is a line underneath there. And since there's a line underneath there, it needs to be a closed circle. And notice which way this arrow is facing. It's facing to the left, so the arrow needs to face the same. This needs to go in the same direction as that one. See how they go in the same direction? Now that it's graphed, I'm going to state my interval notation. You always start on this side of your graph, and as you can see, it's shading to that side. So it's a negative infinity all the way to a negative 2. Notice that the negative 2 is a closed circle, so you put a bracket at the end. Okay, let's do a couple more. It looks like we have 4 more to do, which is good. So here's the next one. We're going to subtract 6 We're going to subtract 6. We're going to have a negative y is less than or equal to 1. I need to get y alone. You always solve for a positive variable in math, so I need to divide both sides by a negative 1. When I divide both sides by a negative 1, this is a negative number, so I need to switch my sign. Do you notice that they're switched? And 1 divided by a negative 1 is a negative 1. My first step is to solve it. My second step is to draw a number line. Well, here's 0. A negative 1, it's situated on the number line to the left of 0. Notice that there is a line underneath it. So at a negative 1, it needs to be a closed circle. And notice which way that this arrow is facing. It's facing to the right. That means I need to go to the right. Do you notice that this arrow and this arrow are pointing in the same direction? Last thing I have to do is I always start here. There's nothing shaded until I get to a negative 1. I need to put a bracket there, and the reason why I have to put a bracket is because it's a closed circle. And I'm going all the way to infinity, and infinity always has a parenthesis. Okay, let's do a couple more. I'm going to add 4 to both sides. I'm going to add 4 to both sides. I'm going to get 5y is greater than a negative 10. I'm going to divide both sides by 5. Notice I divided by a positive number. I do not have to switch the sign. So y is greater than a negative 10 divided by 5 is a negative 2. I solved it. Now I'm going to graph it. Here's 0. Here's approximately where a negative 2 would be situated. Notice right here that there is no line underneath it, so it has to be an open circle. Notice that it's facing to the right, so my arrow has to be in the same direction as my equation or my inequality. I always start right here, and my first answer is a parenthesis, a negative 2 to infinity. Final answer. Okay, a couple more. These are important to do because these are special ones. You already, I think, are understanding how to do those first ones, but why are these special? I'll tell you why they're special when we solve them. I'm going to do the famous distributive property and get 3 times x is 3x plus 3 times 2 is 6 is greater than 3x minus 4. I'm going to bring the x's together on one side by subtracting 3x to both sides. Notice that all the x's cancel out in this problem. That's why this is a special one. And you're left with 6 on this side, a negative 4 on this side, with that greater than signs out in front. When you have no x's left, you have to say to yourself, is 6 greater than 4, a negative 4, sorry. Is 6 greater than a negative 4 on the number line? Is that true or is that false? Is 6 greater than a negative 4? Yes, it is. 6 is greater than a negative 4. When you get no x's left and you get a true statement like this, the answer key is the whole number line shaded in. Every number is going to work in this equation. Every number you can think of will fit in this equation. A shaded number line looks like a negative infinity to a positive infinity. Okay, the last problem is very similar to the one up there. I'm going to do the distributive property. I'm going to get 2x plus 2 times 3 is 6 minus 4 is greater than 2x plus 8. I'm going to combine the 6 and the 4 together to make 2x plus 2 is greater than 2x plus 8. I'm going to get the x's together on one side, so I'm going to subtract 2 x's. But what happens is the x's cancel each other out. I have no more x's left. The only thing I have is 2 is greater than 8. is 2 greater than 8? Is that true or is that false? No. 2 is not greater than 8. Your number line is going to stay empty, which means that nothing can work in this problem, and the solution is a circle with a line through it. So those are the special ones that you need to worry about.